So let's start. I think we were as 35 the question. बस एक सेकंड रुकना, ये हो जाए open. अच्छा this one इसके हम question 35 पे थे. ठीक है, so we were on question 35 just a कौन सा, I think we were right at the end. ठीक है, this part over here. Now so let's complete this. ठीक है, I'm assuming doing this paper we were doing to remember this question. हाँ ठीक है, I exactly remember this question. So let's start with question number 35, and the question states, Abba, can you hear me? So the question is which statements are correct? Chloride ions are oxidized when concentrated sulfuric acid is added to NaCl. No, that does not happen. Remember Cl-1, Br-1, and I-1. Cl-1 does not like to lose electrons. They become good reducing agents down the group. So the reducing power increases down the Cl-1 doesn't really like to lose electrons. It doesn't want to be oxidized. Small atoms, they don't lose electrons. So if the first is incorrect, the second and third are correct. So you don't even have to worry about the second and third. They are correct. But we're going to go through 2 and 3 anyways. 2 and 3 is a disproportionation reaction happens when what happens when cold NaOH is reacted with Cl2. So it's a reaction that you have to remember. So two things are formed. That's NaCl and NaClO plus H2O is formed. Cl is +1 over here and Cl is -1 over here. So it is getting reduced. It's also getting oxidized. So that is what is meant by water. That is also correct, because if you add chlorine to water, two acids are formed. It gets used as a disinfectant. HCl is formed and also HClO. One of them is hydrochloric acid. The other one is chloric 1 acid. Okay. Ibra, is this clear?
Yes, sir.
अच्छा, उसके बाद nitrogen gas is unreactive, whereas oxygen gas and chlorine gas are reactive. Which statement helps to explain the difference? So the main difference is there are two reasons why nitrogen is very unreactive. One is that it's a pretty strong triple bond, so it's very hard to actually break the triple bond. The other thing is that's one very important reason. But the other reason also is that it's non-polar. So it's not. I mean, there is no polarity, which is why there's no partial positive, there's no partial negative charges, which is why it's not going to be attracting other molecules. So the first one is correct. It's a very strong triple bond, and the second one is triple bond between nitrogen atom is not polar, but oxygen and chlorine are also not polar. If the second is wrong, the third is also wrong. Oxygen molecules are also not polar, so this statement is incorrect. And if the second is wrong, the third is also wrong. Atoms in N2 have a full outer shell electrons. Atoms in O2 and Cl2 do not have a full outer shell electrons. They also have a full outer shell electrons. So 3 is also wrong. Aske baad, the next one is the structure of this acid. Which statement about the properties of one molecule of this acid are correct? It contains 2 pi bonds. So whenever you have a double bond, that's a pi bond. So there is a pi bond over here. And there's going to be a pi bond in the carboxylic acid group, because that also has a double bond. So this double bond is formed by a pi bond. So then you have so it contains 2 pi bonds that That is true. It contains four lone pairs of electrons. So does it have four lone pairs of electrons? Carbon doesn't have lone pairs. Carbon has four electrons, and all of it are getting used up. So there are no lone pairs. Uh, Same with H. You've got two oxygens. That's you just have two oxygens. Now each oxygen, whenever it bonds, it has two lone pairs, and there are two of them. So in total, you're going to have four lone pairs of electrons, which is correct. And it has all its atoms in the same plane, which it has all its atoms in the same plane, which is not correct. Uh, I mean, till the double bond part, that is correct. Because if there is a double bond, okay, let me draw the shape of the molecule. So when you have a double bond, okay, I'm talking about this double bond in the middle. Around the double bond, the shape is trigonal planar. It's like a fan, a flat fan, completely planar. There's an H and there's a CH3. And over here, there's a CH3, CH3. And over here, there's a carboxylic acid. That's again a double bond O and an OH. So that's also planar. But apart from those carbon atoms, nothing else is planar. If he had talked about the carbon atoms, then all the carbon atoms are planar. But this CH3, that's tetrahedral, which means one bond is coming out of the page and one is going into the page. This CH3 over here is also tetrahedral. So one bond is coming out of the page, the other one is going into the page. And the oxygen over here is bent because of the lone pairs. So it could be coming out of the page, it could be going into the page, it could be pointing in different directions. Now, so the third statement is incorrect. Is this clear? Isaiah, is this clear? Abba, is this clear?
Yes, sir.
अच्छा उसके बाद question 39 is hydrogen cyanide reacts with the propanone in the presence of potassium cyanide. So this is the nucleophilic addition reactions of
We didn't do 80 earlier.
अच्छा ठीक है
88.
right. हाँ ठीक है. Which compounds on heating with excess concentrate sulfuric acid produces only one product with the molecular formula. So sulfuric acid is a dehydrating agent. I mean, it does a lot of things, but since all of them are alcohols, all these molecules are alcohols. With alcohols, it's going to dehydrate them. So he's saying only one product is produced. What happens when an alcohol gets dehydrated? There's a carbon atom and a carbon atom, and this one has two H's next to it. The OH would be lost, and the H would be lost over here, and the double bond would be formed. Then there's this carbon atom, this carbon atom. This has an H. The OH would be lost, the H would be lost, a water molecule would be produced, and a double bond would be made over here. So this has only one version. Because a double bond is going to be formed over here. And over here, it doesn't really matter if the double bond is on the right side or on the left side. It's pretty much going to be the same thing. So you're going to get exactly the same molecule. There's only going to be one version. अच्छा पे यहाँ पे the OH would be lost and the H would be lost from this carbon atom, and in the middle they would have a double bond. Same goes over here. The OH would be lost, the H would be lost from the neighboring carbon atom. This would be gone, and there's going to be a double bond. There's going to be a double bond over here. So 2 also looks to be correct because there's only going to be one version of this, but not number 3, because the OH and the H would be lost. There's going to be a double bond over here. That's the only place the double bond could be over here. But when you look at this OH, then it has two options. The H could be lost from the carbon above, so the double bond could be over here, or it could be lost from the carbon at the bottom, so the double bond could be over here. So there are basically two possibilities of where the double bond is going to show up. ठीक है? Is this clear?
Still, then in one we also get the same.
Which one?
So we can, in one we get two versions because we can get a double bond on the left or on the right. So
नहीं लेकिन वो मैटर नहीं करता ना कि you basically saying कि ये बन रहा है ना, this is the thing that's forming. The double bond could be over here, right? That's
Exactly.
one. Or the other version is that a double bond is on the other side, right? Over here.
जी, exactly.
So which is going to be the same thing. It's just इसको pick this up and put it उसको left to right flip कर दो, तो it's going to be the same thing.
चलो सही.
Achha, so 1 and 2 are correct, not the third one. Because in the third one you had two options of where to put the double bond. Then you have hydrogen cyanide reacts with propanone. So this is the nucleophilic addition. What happens? What's propanone? It's 3 carbon atoms. Double bond O is in the middle. What's going to happen? The Cn minus one is going to come in with its lone pairs, and the carbon is positive. It's going to attack that carbon positive, or it's going to get attracted to the carbon positive. And when it approaches the double bond over here, it's going to get repelled. The next step would be that that the Cn would be bonded to it, and the O would become minus one. The Cn is going to push all the oxygen lone pair electrons to the top. So the oxygen would become minus one. And in the next step, since it's HCN, H plus one is going to show up and it's going to connect with the O, and a cyanohydrogen is going to be formed. So this is an addition reaction. That's true. It's a nucleophilic addition reaction. Cn minus one is a catalyst. That's why you add Cn minus one, uh, because HCN doesn't ionize that much. So potassium cyanide is added simply because you want to start the reaction. You need Cn minus one right at the start. And the intermediate behaves as a base, which is also true. It's behaving as a base because it's accepting H plus one ions. So the third statement also appears to be correct. And then the last one, which compounds produce three different organic products when hydrolyzed. Hydrolyzed means they're all esters, and the esters are going to break up. And he's saying three different organic products. So the first one, okay, let's focus on the first one. This is going to break up. So this double bond O would turn into a carboxylic acid. The oxygen over here, okay, let's focus on the oxygen over here. So it's going to look like this. This double bond O is going to break up again. So it's going to turn into a carboxylic acid. This one would turn into an alcohol. And then there is this O at the end that would turn into NOH. So you're getting three different products, completely three different products. So the first one is correct. The second one, if you break up all the esters, these two appear to be exactly the same. So, and they're going to turn into alcohol. So it's going to be pretty much the same. It's going to be the same product. There's going to be this molecule. There's going to be a carboxylic acid group over here and a carboxylic acid group formed over here. But the ends are going to be the same molecule. So that's not three different products. So the second one is incorrect. So which is why the third one is also going to be incorrect. Because it's not going to make the third one is not going to make three different products, because this is going to break up. So that's one product. This is going to break up, but that would still keep the molecule intact. Like even if you break the ester link over here, the molecule is still one piece, which is why it's not going to split up. It's still going to be one product. Okay, is this clear?
Yes.
So we're done with the MCQs. I have the same winter 19 question paper 2 3. Okay, so we're going to do past papers for this, just to quickly check. So we had actually done something pretty similar to this, so I'm going to change the past paper. Let's keep on doing an MCQ paper. Achha, for this one we actually didn't do the start. I remember doing this from question number 20. We didn't do the start questions. Okay, the initial ones. So let's keep doing the same paper. We started at the end. Now the question is: diagram shows the Boltzmann distribution of energies in a gas. The gas undergoes a reaction with an activation energy EA. The peak of the distribution is labeled P. If the same reaction is carried out in the presence of a catalyst, which statement is correct? What's going to happen is um, this is the energy axis. So at high energy, the number of particles are very few. And at low energies, again, the number of particles are very few. Most of the particles are, you have the greatest number of particles around the average energy. Okay, that's where the proportion of molecules is the highest. But these are the energetic particles. These are the ones that are going to take part in the reaction, the ones that have more energy compared to the activation energy. So he's saying what would happen if you add a catalyst? What a catalyst would do is, okay, it's going to reduce the activation energy. It's going to bring it lower. So now even these particles which don't have enough energy, even they are going to take part in the reaction. So the shape of the graph or the distribution of molecular energies is going to remain exactly the same. Nothing would happen to it. Uh, so the peak P is at a lower height. That all of them, that's all incorrect. The shape of the graph is not going to change. It's going to remain the same height. So it's either C or D. Position of EA moves to the left. That's correct. So C is correct. So next one is that there is diamond and it's a pure form of carbon, and the mass of diamond can be measured in carats, or 1 carat is 0.2 grams of carbon. Which expression gives the number of carats that contain 6.02 times 10 power 23 carbon atoms? So starting with the first thing, what's 1 carat? 1 carat is 0.2 grams of carbon. So that's 0.2 grams of carbon. And you basically are interested in the number of carats. First thing is convert this into moles. How do you convert this into moles? It's 0.2 divided by 12. Okay, so it's these many moles. That's 0.2 divided by 12. So 0.2 divided by 12 moles is basically equal to 1 carat. What he's looking for is, okay, how many carbon atoms is this equal to? So we're going to use ratios and we're going to say, okay, 0.2, I mean, these many moles is equal to 1 carat. So 1 mole would be equal to how many carats? And we're going to cross multiply. And if we do that, this is the X that we're going to try and find out. If we do that, it's going to come out to be 12 divided by 0.2. So C is going to be the correct answer in this case. ये वाला clear है? Rida, is this clear? Zaib, is this clear?
Yes, sir.
Next is which molecule or ion contains the smallest bond angle? So the angle C2H4 is ethene. That's a double bond. Carbon, that's fan shaped. So there's only one angle over here. That's 120 degrees. So what about this one? This one is going to have two types of angles. It's a ketone, so that's C double bond O. So again, that's 120 degrees. But then there is a CH3. CH3 is tetrahedral. 4 bonds is tetrahedral. This is that's 109.5 degree angle, and this one is 120 degrees. What about NH4 plus 1? That's 4 bonds. 4 bonds is tetrahedral. So again, that's 109.5 degrees angle. NH3 is 3 bonds. And on the fourth side, there's a lone pair. Because of the greater repulsion, the angle is 107 degrees, which is why D is going to be the correct option. As for next one, 4 compounds are shown. How many of these compounds have an odd number of sigma bonds? So, what's a sigma bond? A sigma bond is whenever you see a single bond, that's a sigma bond. Any single bond. Whenever you see a double bond, here let's that's one sigma bond. Whenever you see a double bond, that's still one sigma bond. Whenever you see a triple bond, that's still one sigma bond. So the question is odd number. So first one is ethene. So how many sigma bonds is this? That's 1, 2, 3, 4. Double bond is 1, so that's 5. So that's 1. It has an odd number of sigma bonds. The next one is C2H5OH. So all of them C2H5 and OH. So another all of them are sigma bonds. So that's 1, 2, 3, 4, 5, 6, 7, and 8. That's that doesn't have an odd number of sigma bonds. As if we move to the third one, which is an aldehyde, CHO is double bond O and H. So how many sigma bonds do you have? That's 1, 2, 3, 4, 5, and 6. Again, that's not an odd number. So far we have one. I said, what about the last one? It's CH3. और उसके बाद there is single bond O and OH. So that's 3 over here, 4, 5, 6, and 7. So that has an odd number. So it's basically 2 is the answer. I said next one is ethanol, and methoxymethane are 3 organic compounds. Which compound has the highest boiling point, and what is the interaction that causes the boiling point to be higher? So anyone, can somebody tell me which one has the highest boiling point?
Ethanol.
Ethanol.
ठीक है और उसकी and obviously why
Hydrogen.
ठीक है it has hydrogen bonding ठीक है so it's going to be C. Hydrogen bonding bonds are, if the size is the same, are relatively the strongest. So what's the oxidation number of sulfur in each of the species? It's this one is clearly +4. What's the oxidation state over here and over here? क्या रही है anyone?
-2 on the first and +4 on the last.
ठीक है, so last one is +4. ठीक है, this is -6, this is +2, so this would be +4. So it's
So
going to
we
be
have
A.
an overall -1 charge on SO3, right? SO3 molecule.
No, H2SO3, it doesn't have a charge.
I'm just talking about an SO3 molecule.
खाली there's an SO3 molecule which has no charge. ठीक है, that's one version. ठीक है, that's a sulfur trioxide molecule. जो ये contact process में नहीं होता. Ibrahim, you can
Like that.
ठीक है. And then there's an ion which is different. It's SO3 -2. That's a sulfite ion. As the next one is you're given enthalpy changes of formation. So if you have an equation, or उसके अंदर you know the enthalpy of formation of the reactants, like over here you know the enthalpy of formation of this thing. You know the enthalpy of formation of N2O4 as well, which is this one. And you know the enthalpy of formation of H2O as well. What is the value of the enthalpy of formation of N2? ठीक है, that's going to be 0. ठीक है, so that's 0. So that means you also know that. So if in a reaction you know the enthalpies of formation of the products and the reactants, so there's a simple formula to figure out the enthalpy of the change of that reaction. That's products minus reactants. That's enthalpy of formation of products minus the enthalpy of formation of reactants. Somebody should solve this. You have to be very careful with the moles and use brackets ताकि you don't make any mistakes. So the products is 3N2, that's 0. So forget that. 4H2O, so that's 4. multiplied by minus 241.8. So that's your products minus the reactants. So the reactants are 2N2H4. So that's 2 times 50, 2 times 50.6. And the other one is N2O4. There's only one of them. So that's so that is just input 9.2. Can somebody tell me what the
Actually,
answer?
minus 8 P.
Okay.
B minus 856.8.
ठीक है. I said just be very careful with the moles. ठीक है. On enthalpy change calculations, any one of those calculations, be very careful. ठीक है. Make sure recheck every step. If you just make one tiny mistake, even if you know how to solve this, you're going to get a wrong answer. As the next one is sodium burns in oxygen and gives out heat energy and forming the compound Na2O. The equation for this reaction is shown. Which statement about, so this is sodium burning in oxygen. The enthalpy for the reaction is equal to twice the bond energy of the NaO bond. So is the enthalpy, my kisi ka on hai? I said the enthalpy for this reaction, is NaO bond the only thing that's getting formed over here, or are you breaking any bonds in this reaction?
We're breaking oxygen bond.
I mean, you're breaking oxygen bonds. You're also breaking the sodium metallic bonds because it's a metallic solid. So you would be breaking these bonds as well, and you would be breaking the oxygen bonds as well. So the enthalpy change would not just be equal to this thing. So which is why the first statement is incorrect. The enthalpy for the reaction is positive. How do you know it's not positive?
Because bonds are being made.
But they're being broken as well. But you are breaking the oxygen bond.
Because it is a combustion. Is combust.
Like the
Experiment.
obvious thing is because he said so. Okay, it's giving out heat energy. Okay, so it's exothermic. लिखा हुआ है ऊपर, ठीक है. अच्छा, next is the equation represents the standard enthalpy change of combustion of sodium. Is that true? What is, and remember standard enthalpy change of combustion. Well, what is the definition of enthalpy change of combustion? That how many moles of sodium should combust?
One more.
So which is why it's wrong. It's 2 moles. So it's not. I mean, you could have said it's 2 times the enthalpy change of combustion. So here it's going to be correct. Not this one. The next last one is the equation represents the standard enthalpy change of formation of sodium oxide, and that's true. 1 mole of sodium oxide is formed from its elements, and the elements are in their standard states. So 1 mole of the substance is getting formed, hence its enthalpy of formation. As the next is you're being asked to balance this equation. It's a redox equation. So how do you balance a redox reaction? Uh, First thing is figure out the oxidation states. Cl is +5 over here. Mn is +7. But you should, I mean, this should be remembered by heart. I mean, it's MnO4 -1, that's +7. ClO4 -1. What's the oxidation state of Cl over here? Okay, कोई idea? Just 1 second. ठीक है, it's +7. Okay, this is +7 and this one is +4. H is +1 and O is -2. Achha, so what's happening? Remember the number of electrons gained and lost, they have to be made equal. So what you're going to do is this is going from +7 to +4. So that means it's gaining 3 electrons. And this is going from +4 to +7. So that means it's losing 2 electrons. What would you multiply the two numbers with? You're going to do multiply this by 3 and multiply this by 2. So there should be 2 Mns and there should be 3 Cls. I mean, that's what the ratio is going to be. and then you can balance the rest of the equation. It's now try balancing the rest of the reaction. How many oxygens in total do you have? That's 3 3, that's 9. 2 4, that's 8. So 17 oxygens. Just to double check, that's 8 and this is 9, so that's 17. So you got 17 oxygens. 17 oxygens on the right side as well. So that's 3 4, that's 12. 12 plus that's 4. So you just need one oxygen over here. So Z would be 1. And now you can try and balance the number of hydrogens. So Y is going to come out to be equal to, there is no hydrogen anywhere apart from here. So Y would come out to be equal to 2. Is this clear? The correct answer would be the last one. Kya tha? W, X, and Y. 3 2 2. So that's going to be D. So is this clear?
Yes,
You
sir.
I should just make sure that the number of electrons gained and lost are equal. So then you have an equilibrium reaction and two compounds as X and Y are reacting to produce compound Z. The reaction is reversible. So there's X plus Y in equilibrium with Z. When X and Y are mixed together in a closed system, a dynamic equilibrium is gradually established. Which graph could represent the change in the rates of the forward and reverse reaction over time? So, Acha, what's going to happen to the rate when equilibrium is reached? They would become. क्या होगा? What happens when equilibrium is reached?
Forward reaction is equal to the backward reaction.
The rate is equal. So it's either going to be this one, not this one. This means it's not at equilibrium. Okay, the dotted line represents the forward rate. So it's basically this one. They're going to become equal once equilibrium is reached. All the rest are not at equilibrium. Uh, B can the what's happening in B, the rate becomes equal to 0. That means there is no reaction happening, whether it's the forward or the backward. The rate has come down to 0. Nothing is happening. If you look at D, uh, the reverse reaction is happening at a very fast pace. The forward is not happening. Its rate is dropping to 0. Over here, the rate of forward reaction is still faster compared to the rate of the backward reaction, which is why it's not at equilibrium. So this is the one that's at equilibrium. So C is the answer. So next is the reaction between sulfur dioxide and oxide is reversible. So the Kc value is given, and so the equilibrium concentrations are also provided. What's the Kc expression for this? The Kc expression is going to be product concentration, that's SO3 concentration, and that's going to be squared. And divide that by SO2 concentration. That would be squared as well, divided by O2 concentration. Now you have the value of Kc that's already given, it's 280. And he's already given you the sulfur dioxide concentration and the oxygen concentration. So you're looking for the sulfur trioxide concentration. That is unknown. Dioxide is given as 0.2 mole per dm cube, and that's squared. And O2 is given as 0.1, so that's power 1. Somebody calculate this and tell me what the value is.
1.058.
Okay, so it's A. So which, now this is inorganic, which oxide will cause an increase in pH when added to water? Increase in pH means basic. Which one is basic?
MgO.
MgO is the one that's basic. Although it's very, very weakly basic. MgO is not very soluble. If you dissolve MgO, very slightly it's going to dissolve. And the pH would be around 8. But at least it's going to increase. Aluminium oxide is not soluble in water. SiO2 is not soluble in water. Sulfur dioxide is soluble, but it would make sulfurous acid, which is going to make it strongly acidic. X and Y and Z are consecutive elements in period 3 of the periodic table. Element Y has the highest first ionization energy and the lowest melting point of these three elements. So this question asks, so the melting points. How do the melting points vary across period 3? Sodium is, then there's magnesium, aluminium, then silicon, giant covalent structure. Then you have, uh, after that, you have sulfur, the phosphorus, then sulfur, then chlorine and argon. So it's Na, Mg, Al, silicon, phosphorus, sulfur, chlorine, and argon. So that's your melting points across the period. Okay, you have to remember all of this. Now he's saying that the one in the middle, the Y, okay, there are three consecutive elements. So it's either NaMgL or MgAlSi. So three consecutive elements. The middle one has the lowest melting point. So it's either going to be, I mean, the only option that you have, I think, is phosphorus. Because if you have three consecutive elements, the only possibility of the middle one having the lowest melting point is this one. So it's going to be D. You don't even have to look at the other things. It's going to come out to be D because any three consecutive elements, the middle one is not having the lowest melting point. If you pick Mg, Al, and Si, Al has a higher melting point compared to Mg. If you pick Al, Si, P, then Si is not going to have the lowest melting point. So by default, it's this one. So Y is P and this is Si and this is S. Okay, is this clear? Rida, Hiba, is this clear? Abba, is this clear? I said then, Balki, we will also go through the ionization energies. What happens? We didn't even discuss the ionization energy. He was saying that Y has the highest ionization energies. So what happens across the period? What happens to the ionization energies? It increases across the period. Sodium
Yeah.
has the lowest. Then there's a dip at group 3, 4, 5. Then there's another dip at 6, then 7 and 8. So phosphorus is over here. It's so out of the three, phosphorus is going to have the highest ionization energy between the three. And so now, next is a 5-gram sample of group 2 nitrate loses 3.29 grams in mass when heated strongly. Now, there are two ways of doing this question. One is the trial and error method that you can pick magnesium. So there's a nitrate, right? It's a so what you could do is one by one you can check. Okay, I mean the statement is true for which metal. You can pick magnesium, and you can figure out that it decomposes to form MgO plus 2NO2 plus O2. So it's this is 5 grams, and it loses 3.29 grams in mass. So this is we're assuming it's the gases that are lost. So how much do you have? That's 1.71 grams, right? So that's one way of uh, trying to figure this out. What you can do is trial and error, try and figure out the moles of this thing. Just a second. I said try and figure out the moles of this thing. Can somebody tell me the moles? It's 5 divided by 148. Just one second. NO3, that's 14 plus 16 into 3, that's 62 into 2, that's 124 plus 24, that's 148. How many moles do you have?
0.033.
So you have 0.033 moles. So MgO moles would be 0.033 as well, right? And you can find the mass 0.033. Are you sure it's 0.033? multiplied by the MR of MgO, which is 24 plus 16, that's 40. What is the mass that we're getting?
1.35.
ठीक है, so it's the 1.71 नहीं आ रहा, ठीक है, that's not the one that you're getting. So that's one way of figuring this out. कि one by one go through each option. Lekin if it's the last option, then it's very time consuming, so you don't have enough time. The other thing is, what you could do is you could so the other thing is, let me remove this. Now the other way of solving this question, take the metal as the unknown nitrate. Okay, so I'm going to remove Mg. I'm just going to take it as an unknown metal nitrate. And since it's group 2, so M has a charge of +2. According to the equation, the moles of the two substances should be equal. This is 1.71 grams. And this is 5 grams. Now, how do you find moles? You find moles by dividing by MR. So I don't know what the MR of M is, but I know that NO3 twice, that's 124. And how do I find the moles of MO? I know that it's 1.71 grams. And I'm going to divide that by the MR, which is M plus 16. The two moles should be equal because according to the equation, they have the same ratio. So you're just going to work out this and figure out what M is. So can somebody try and find or calculate what M is?
So I didn't get this. Okay, why did he equate both of them?
Hmm?
I didn't get why did he equate both of them?
I say, you know, clear enough. Okay, let's forget this. Is this clear? Okay, that's how you're going to find the moles of this substance, right?
Yeah, exactly.
Okay, 5 grams divided by the MR, right? How do you find the moles of MO?
Again, 1.71 divided by
Divided by the MR, right? So what does the equation tell you? The equation tells you that the equation is telling you, okay, if this had 10 moles, the amount of MO would be produced would also be 10 moles, right?
Hmm.
तो उसका मतलब है, whatever the moles that you get for this, this should have exactly the same moles. Is that clear है?
जी.
तो इसलिए just equate them together. So it's going to be 5m plus 16 into 5, I think, is 80. The other one is 1.71 m plus 124 multiplied by 1.71, and you can make m the subject of the equation, so it's going to be
42.9
42.
calcium.
पता नहीं 42 exact आना चाहिए वैसे. It's 1 second. It's going to be 124 times 1.71 minus 80, and divide the whole thing by 5 minus 1.17.
So वहाँ पे MR आपने 124 लिखा है, which is actually 110 NO3
नहीं किसका?
NO3 का the
नहीं यहाँ पे
MR
गलत
is
था. नहीं वो that is 124.
नहीं, अच्छा हाँ जी
ये गलत था. It wasn't 1.171, it was 1.71. ठीक है, this was actually 1.71.
अब 34.4 आ रहा है.
34 point.
एक मिनट गलती की है.
Sir, I'm getting
सिर्फ
40.1.
40.1.
ठीक है, अब कैल्शियम है. ठीक है, वो 1 point उसका मिस्टेक था. 1.17 कर दिया था, 1.71 है. चलो ठीक है. So just remember that's one way. I mean, this question came I think it came 3 times. Okay? It's probably the third time it's appearing in the papers. So just remember, there's some quicker ways, because the other way around, that's going to take a lot of time. So okay, let's continue with the same paper next time. Okay, we just left with a few questions in this paper. Okay, then take care.
Allah Hafiz.
Allah Hafiz.
Office.
Cheers.